Okay, so in Theorem 9.5.2, we will be pretty much generalizing what we worked on when we were working on the problems with the teams where there were women and men on the team. So it gives us a formula and it kind of justifies why I was able to multiply earlier in that problem. Okay, so the formula is written right there in the middle of the page, but here's how we're going to use it. Suppose I want to reorder the letters in the word Mississippi. The question is, how many distinguishable orderings are there? Okay, by distinguishable, we mean that how many different words can there be? You know, some of the letters are repeating in here, so, you know, how many possible choices can I make? Okay, first of all, how many letters are in the word itself? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are total of 11 letters. So the total is 11 letters. Okay, and some of these letters are M, and some of them are I's, and so on. So let's make a tally. How many M's are there in this problem? Okay, so going back to the word, there is one single letter M. Okay, how many I's are there? There are 1, 2, 3, 4 letter I's. Okay, now what about the S's? There are 1, 2, 3, 4 letter S. And then finally the P. How many are there? There are 2 letter P's. Okay, so at this point, since I have tallied up all the letters and figured out how much there are of each one of them, the question is, I want to make a word. What should I do? So first of all, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters to pick. So what can I do? Well, I could figure out where the M goes and then just forget about it. Okay, so the next time I do this, I can pretty much pretend like the M is not even there and now select where the I's go. So like for instance, I could put the I's right there, right here, and right here. So now the M's are basically finished, they're done. The I's are basically finished and done, okay? So next, I would have to select where the S's go. So notice how now there's no more I's, there's no more M's. Those locations have been pretty much eliminated. So what I have to do now is put where the S's go. So there are 4 of them. So let's say I put 1, 2, 3, and 4. So there it is. So the S's are now taken care of. And then finally, I gotta place the P's. Well, in that case, I only have 2 locations, the first one here and the last one there. And so at this point, my problem is pretty much finished. So at every layer, I added an extra set of numbers, okay? So at the beginning, how many choices did I have for the M? So I had 1 letter M, and I had 11 possible places to put it. Then I basically put the M, and now what? Now I have 10 choices, and I have to put 4 letter I's, so that's 10 choose 4. But once you select all the I's, how many locations do you have available? 1, 2, 3, 4, 5, 6. And you had to put a bunch of S's in those positions, okay? So you had 6 positions left, and you had to put 4 S's in there. Once you did that, there were 2 left positions, and you had to put the P's in them. So there were 2 positions left, and you had to put 2 P's in them, so 2 choose 2. So that's where the first part of the formula basically comes from, okay? And now, since every M can have a different combination of I's or S's or P's, you'd have to multiply all the numbers at the end. So that's kind of the reasoning behind why the formula works, okay? So at the end of the day, the total that you're looking for is something like this. It's 11, choose 1, multiplied by 10, choose 4, multiplied by 6, choose 4, multiplied by 2, choose 2. We'll figure out what this number is in a second. We'll put it in the calculator. It's a really big number. But, you know, I chose the M's first, then the I's, then the S's, then the P's, but anybody else could have done it in any different order. It's not relevant what order you pick them in. You could choose the I's first or the P's first or whatever, okay? So let's say you choose a different combination. It's going to work out the same way, okay? Now, another way of writing this down is to use the simplified version of this. The simplified version of this says put the N first. What is N in this problem? It's the total of how many letters you started the problem with. So 11 factorial goes on the numerator, okay? So that's the N. Now put N1, N2, N3, and so on. So what is N1? It's basically how many of the first letter there were. So put 1 factorial. Now, what is N2? It's how many of the second letter there were. So in this case, it's 4. And then again, factorial. and then put n3. What is n3? It's how many of the third letter there were. So in this case, again, 4 factorial. And finally, put nk, which is in this case 2. That's the last, which is 2 in this case. Okay, and again, factorial. Now, if you look at the simplified version, you'll notice that the order of the things on the denominator is irrelevant because it's all multiplied. So you can put the 2 first, the 4 first, whatever. So this is equivalent to saying it doesn't have to be the case where I always choose m first. I could choose the i's first, or the s's, or the p's. It's irrelevant which one I pick first, which one I pick next, and so on and so forth, as long as all of them make it to the list. So at the end of the day, it's going to be 34,650. Basically words. That's how many words you can make out of the letters in the word Mississippi. Okay. Now, you can choose either way to get the answer. It's not really relevant, but just keep in mind that when you're using the formula over here on this side, you're going to start always with the 11 on the very first number, and then you're going to basically put 1. In this case, 1 represented how many m's there are. Now, you don't have to do that. You can put the i's value, which is 4, or the s value, which is 4, whatever, it doesn't matter. But the next number right here on top is going to be 11 minus 1, which is 10. And then you put whatever letter you want, and then again, the next number is going to be the 2, 10 minus 4, that goes there. And then you put whatever number you want on the bottom, and then 6 minus 4 is going to be 2, you put that on top. So that's a quick way of getting the answer without having to memorize all the formulas. Okay. So that's, that's also going to work. So let me give you an example. So here's another possible way of calculating it. So for example, I could put 11 because that's how many letters I began with, and then I want to put the s's first. So I'm going to put 4 there. Now, 11 minus 4 is going to be 7, so the next spot is going to have 7. And then I could put, let's say, the p's afterwards, which is 2. Okay, so once you've chosen the p's and the s's, now you have to select either the m's or the i's. It does not matter. So let's say I selected to put the i's next. So 7 minus 2 is going to be 5, and I'm going to select the i's after, so that's 4 of them. And once I'm finished, 5 minus 4 is going to be 1, and then I have to put the final letter, which is the letter M, and there's only one position to put it in. Okay? So regardless, the answer is still going to be 11 factorial divided by, again, according to this formula, you're going to put the n1, which is the first number, the n2, which is the second number, the n3, which is the third number, and so on and so forth. So basically, all I have to do now is put the bottom numbers, 4 factorial, 2 factorial, 4 factorial, 1 factorial. So as you can see, this expression is equivalent to that. It's the same thing. It's just multiplication. The order does not matter. So we get the same amount, 34,650 at the end. So again, regardless, it's the same thing.